So this is text analytics for contract understanding. So we're all kind of frequent users, I suppose, of legal contracts and end user agreements and other similar documents. But these are notoriously hard to understand if you're not a legal professional. So, you know, we all talk about reading the small print. And I know personally, I can't really understand many of these documents, and I don't also want to invest the time usually in reading through reams and reams of pages of this kind of small print when I'm just maybe downloading an app, for example, or some small task. And that's the case that we regularly accept these type of contracts and agreements without any thought when we sign up to things like new services or apps, or when we create an account on a website, for example. However, in the current age, there's very much more increased awareness of data privacy through regulations such as GDPR. And also we're more aware of the value of our own data, and that we want to be protective of the data we're generating, and also to make sure where that's being used, and is it being used in a way that's going to benefit us, or is it going to be used in a way that's going to maybe at the least infuriate us when we get a load of marketing email, for example, which will be the sort of least problems, I think, of a data breach, or it being used in some way that we didn't sign up to. So there's a need to be more aware and informed of what's actually included in these types of agreements and contracts that we regularly click OK to. So there's been a lot of recent improvements in the fields of text analytics and natural language processing. And so there's an opportunity here for these techniques to be applied to help analyze and help interpret these kind of complex documents. So the goal of this project is to explore natural language processing and text analytics techniques to aid with the understanding and interpretation of contracts and end user agreements and these kind of documentations for non-legal professionals. So these are sort of everyday users that might come across these. So to introduce the team, the lead researcher is Michael Spence, with support from Anupam, who is on an internship with CeADAR, and Saad on the implementation support. And the company partners are Accenture, AIB, Bank of Ireland, Fidelity Investments, Fidelity International, KBC, Liberty, Munich Re, Verisk, Even Better Value, Vodafone, OrcaWise, Version 1, and BPI Unitech. So to look at what's the state of the art in this kind of area, well, you know, not surprisingly, there's a large amount of academic work that's been published on NLP for contract understanding. And there's also many companies also working in this area because, you know, this need is not a unique thing. It's well known, well understood. And there's been systems developed to extract contract elements automatically. So these can be things like automatically extracting end and start dates in types of contracts that have that information, extracting the contracting parties, and whether there's references to legislation within a contract. And also by finding obligations and commitments in contracts, there's systems to automatically check for regulation compliance. So for example, automatically seeing whether a contract is GDPR compliant, and also for construction contracts, for example. And the systems like Bloomberg Law, and these can be used to aid contract drafting. So these are actually designed for legal professionals themselves by analyzing past examples and learning from them and suggesting aspects when drafting new contracts. However, many of these systems, they're still aimed at legal professionals or specialized legal domains. So they're more like tools within the trade rather than tools for the everyday user. So there's definitely a need for tools to assist the average person who doesn't have legal expertise. They don't have time to invest maybe in reading through these as well. And they often have to make decisions on complex end user agreements many times a day. So just these are three examples here that over the last couple of weeks, I've actually come across in my own use. So Amazon Privacy Notice is a multiple page document there. If you sign up to any Amazon services, Amazon Prime, for example, you are automatically agreeing to that privacy notice. Roblox, my kids are playing that game at the moment. I didn't even look when I downloaded that or signed to accept that, because it's, again, multiple pages. It's complex clauses in it. And Slack, for example, if you download the new version of the application, they have a privacy policy. Basically, every service would have one of these from any reputable company. And I haven't read any of those that I've signed up for in detail ever, probably. So the Demonstrator is a web application, and it's built around a machine learning based classifier. And what it does, it provides additional information and context extracted for end user agreements for app downloads. So, for example, Android apps. So on the left-hand side below there, you see this for every page for any app on the Google Play App Store. This details are at the bottom, and there's a privacy policy link, and every single app has one. And this will point you to the privacy policy on the developer's website. So every single app has one of these. And the classifier in the Demonstrator that we've developed is trained using a public data set called the App 350 dataset. And this is 350 example end user agreements, which have been professionally marked up by legal experts. So they're labeling the data to allow the training of models on this. It's a public data set, and we've trained our own prediction models based on this public data set. The interface then has been designed to provide pertinent and intuitive information about the terms and conditions in an end user agreement, which is designed in a simple way to allow the user to quickly analyze and understand what are the key bits of information that they are signing up to, and whether that's something they actually want to agree to. So I'll now hand over to Michael, who's going to run through the live demonstrator.
Cool, thanks very much, Oisin. I'll just share my screen here. Okay, yep, so here's the demonstrator here. So as Oisin said, the purpose of this is you would give it a link to a privacy policy that you would like to understand better. It automatically extracts the text from that page and then runs like a quick analysis on it and returns you a report outlining like what kind of data is recorded by the company and who they share it with. So I'll just describe the page here quickly. So you have two options. You can enter the web address of a policy. But in some cases, like some websites might not be compatible with our systems. So if that happens, you can just enter raw text here in this box. Yeah, there's a feature at the bottom here, which is the same as the other demonstrators, where you can see all the previously processed jobs, which is useful. So we can run a quick analysis on a policy here. So this is the privacy policy for a company called Jam City, which make games for Android. And as you can see, it's pretty long. You know, there's like lots of information here. And I think very few people would have the time to read something this long. And even then, like a lot of the language is quite legalistic and difficult to understand for the average person. So yeah, our program tries to help with that problem. So we take the URL and we just copy and paste it here. And then run the classifiers. So this normally takes about 20 seconds for a policy of this length. So what it's doing is it's going to the web page, extracting bits of text like roughly corresponding to paragraphs, and then it's running the classifiers on every one of these paragraphs. And you'll see the results displayed here shortly. Yeah, so here they are. So the first thing a user is going to see is these graphs here. And what they tell you is what kind of data is being gathered and how many mentions this kind of data has in the policy. So how many of these paragraphs talk about this kind of data. And the kinds of data are split into first-party practices and third-party ones. So a first-party practice is something which the app publisher will gather directly, whereas a third-party one is information that would be passed on to advertisers or some kind of analytics services. Yeah, so you can see here, like in this policy, demographics are only mentioned once, or only detected once, whereas cookies is detected 4 times, you know, so there's a greater weight on that. So down at the bottom of the page here, we can see the actual bits of text which were detected as like mentioning practices. And this color coding means, so if a bit of text is green, that means our models are confident in the prediction that's been made, or very confident. If it's yellow, it means they're slightly less sure. And the lowest level of confidence in a prediction is color coded orange here. So you have 3 different colors. So we can look, for example, at the cookies, which bits of text have been flagged. So here we can see, yep, cookie identifiers are mentioned here. And the first bit of text there says, we may also collect. So that's a first party practice. That's the app publisher actually collecting this information. And then again, you can see here, like, more cookies have been mentioned, and pixel tags as well, which comes under this header of similar technology. Yeah, and then you can also see, for example, there's 2 mentions of location as well. So these bits of text here, it says here location information, including inferred location based off IP address. And then also in this one here, it talks about geolocation information. So we can also look at the third-party practices here. So you can see there's quite a few mentions of IP address. There's 3 mentions. So here, yeah, So here you can see there's a mention of third-party websites and third-party services, just in this bit of text here. And then later on, yeah, it talks about IP address here and here. And it's the same thing in the other 2 bits of text. So one third-party practice which is talked about commonly is what's called single sign-ons. So this is when, like, when you're using an app and it offers you like access to you know, some kind of integration with Facebook or Spotify or something. So if you sign into a third-party service on an app, then these 2 apps will they'll exchange information with each other. So you can see here under this SSO header, there's a bit of text saying, if you sign up to use the services via third-party social networking sites, yeah, so that means they will trade information and share information with each other. And then there's a particular header here just for Facebook. And you can see, yeah, there's a single sign-on option for Facebook in this app as well. So yeah, the reason I chose Jam City is because there's quite a variety of different practices mentioned. But there's a lot of, you know, variation in what kind of practices policies describe. So I'll try a different one here just to demonstrate the variation you get. So this is quite a pertinent example at the moment. This is the COVID tracking app, which the government has just put out here. And as you can see, it's much shorter and much more concise than the Jam City one. So we can run a quick analysis on this and see what it gives us. Yeah, so here we can see there's a lot fewer practices detected, and only 1 third-party practice has been detected as well. Yeah, so like this is what we'd expect, I think. Like, so the phone numbers collected, obviously they need that if they're gonna like call you if you're a close contact with someone who's tested positive. Demographics like age have been detected, so that'll be useful for health purposes and things, and like tracking what kind of people are being infected now. And also location will be important as well. So one interesting thing I noticed on this one is it detected contact address book. So this is when like an app would have access to all the phone numbers of your contacts and everything. And that's not quite what happens here. So what happens is, even if you haven't installed the app and someone you've been in close contact with has tested positive and they have the app, you will get a phone call. So what it does is it stores the phone numbers of all your close contacts, even if they don't have the app. So that's what the contact address book means, and it's good it's detected that, because that's an important piece of information. So yeah, also as I said earlier, you can see that there's only one third-party practice which has been detected, which is what you'd expect because it's a government app. Like it's not going to be running advertisements or anything, so there'd be very little need to share information with anyone else really. Okay, yeah, I think that's a good summary. I think of the demonstrator and how it works. So I will hand back to Edward now, I think.